Good afternoon, everyone. It's at the top of the hour. Are you ready to begin? I see lots of hands going like this. Maybe someone from the library can give me a thumbs up.
We're good.
Okay, great. Well, good afternoon, everyone. My name is Patricia. And did the library want to say some opening remarks? I'm sorry.
Yeah. So I am so excited to see so many of you here. I am really thrilled that we got this awesome opportunity. We have some amazing people from NASA that we are going to introduce. They're going to introduce themselves as we go, but we are so excited to get to have an actual engineer who contracts with NASA speak to us today. So we are going to let them introduce themselves. They will do a presentation. And then if you didn't already get paper and pencils, we have those. Take notes of any questions you want to ask. And at the end, you can come up and ask them questions. And then we'll go to that point. So we want to welcome them.
All right. Well, thank you guys for having us. Again, my name is Patricia Moore, and I work at NASA in our communications group. And our job is to help share NASA's story with people just like you. And we're very fortunate to have Jessica Rose, who works for Northrop Grumman. And Northrop Grumman is a company that works with NASA to help build the rocket that's going to send humans back to the moon. So I'm going to turn it over to Jessica, and she's going to tell you all about Artemis and her role and what she does as an engineer. And then we'll answer questions at the end. So take it away, Jessica.
All right. Thank you, Patricia. Well, to start off, I want to hear how excited you guys are. All right. Good. That's about how excited I am too. This is a big deal, and I see this every day, but I am so excited. We're going again. Artemis is launching. We're going to go back to the moon. I'm going to detail more of that throughout this presentation. And I'm going to show you guys some just awesome videos of the work and the mission that this is going to accomplish. So to start off, I'm Jessica Rose. I work at Northrop Grumman. I am a chemical engineer. I started at Northrop Grumman in propellant engineering, where we manufacture the boosters that boost the SLS segment out into orbit. They're the two that you'll see on the side of my picture, and you'll see them further in the presentation. Northrop Grumman manufactures the boosters portion of it, and we partner with a few other companies such as Boeing and Lockheed Martin and Rocketdyne or Aerojet Rocketdyne to make the SLS segment. So to start off, I'm going to have a video, and then we'll go on and talk a little bit more about it.
We're going to the moon to explore, and we're going to the moon for scientific discovery. Our destiny is always to go and see what's further and what's next.
The moon is a stepping stone, and the moon is a place we need to learn how to live so that we can continue to go beyond. We are focused. We are focused on all that lies before us. Only together will we bring to life this global ambition of returning to the moon. And while our work is far from finished, we've never been closer to seeing a new generation step beyond our home planet. We are building on the achievements of those who came before. The giants who conquered gravity and raised a banner in the heavens. They beckon us to go farther, to the moon and on to Mars, to seek a deeper understanding of our universe and bring all that we learn home. The daily efforts of thousands of survivors from all across this country and around the world fed into stunning milestones and laid the groundwork for history.
Launch team, go.
Artemis has been woven into our culture. It has fostered collaboration across the aisles and across the ponds. It has grown beyond plans and preparations to include hardware and software. And now it has a heartbeat. You can feel the momentum. It is undeniable. We are going. And together, we will see Artemis light the way. We are going to the moon to learn how to live on other planets for the benefit of all.
Let's go.
All right. Well, if that didn't get you even more excited, there's a few more videos too. So a little bit more about myself. As I mentioned, I'm Jessica Rose. I was born in Idaho, which is not far from where we manufacture these boosters here in Utah. I'm the youngest of 5 children. I was raised farming and ranching for most of my childhood years, so it's pretty surprising and a great opportunity that I ended up into the space program, and which really thrills me because I didn't know that I would be able to, and you know, it's a great opportunity to be able to be here. So I attended the University of Idaho, where I studied chemical engineering, chemistry, and then material science engineering. I graduated in 2016. I'm currently working on my Master's of Engineering Management at Kettering University in Michigan right now. I am married to a entrepreneur who has a landscaping business, and I have a spunky toddler that absolutely loves doing science experiments, as you can see there. We do them nearly every weekend, and I just love that she's as fascinated with space as I am. I have many you know, activities that I love doing. I love trying anything new and thrilling. As you can see, I went skydiving. Not sure if I'll go do that again, but I at least have done it once. And then I actively teach STEM activities to youth, as well as my daughter, and then do presentations such as this one to encourage and motivate you know, young individuals to go into the space program and get them excited about it. And then a fun fact about me is I absolutely adore camels. It is a weird favorite animal, but I got to say that they're the most fascinating animals on Earth. So a fun fact about me. All right, so what is Artemis and why do we have the name Artemis? Well, it's the twin sister of Apollo, and it's the goddess of the moon in Greek mythology. Artemis is the torch bringer, personifying our path to the moon, the next era of human exploration, and we'll discover life-saving, earth-changing science and technology along the way. NASA's goal with Artemis is to land the first woman and the first person of color on the moon and return them safely to Earth afterwards. When the Artemis astronauts lands on the lunar surface, they will step into the future and bring all humanity with them. So that was a really exciting mission to be a part of. Here you can see SLS. So this is our space launch system. This one in specific is Artemis 1, which we are targeting to launch on August 29th. And this is going to be an uncrewed spacecraft, which you'll hear a little bit more about the different missions for the different Artemis, Artemis 1, Artemis 2, and Artemis 3. And I'll describe those more into detail. But anyways, it's time for another video.
Artemis 1 will lift off from Launch Pad 39B at NASA's Kennedy Space Center in Florida with 8.8 million pounds of thrust provided by the most powerful rocket in the world, our Space Launch System rocket, or SLS. The uncrewed flight will be the first integrated test of SLS, our new Orion spacecraft, and exploration ground systems at Kennedy. Artemis 1 will send Orion beyond the moon, 280,000 miles from Earth, farther than any human spacecraft has ever flown.
This is not NASA doing this. This is the United States of America doing this program, the Artemis program. And there are companies all across our country that have a part in it. So there is kind of this wave of excitement being generated just by saying, we're going back to the moon.
After the upper stage of the rocket separates from Orion, the upper stage will deploy small satellites over several days to perform science experiments and technology demonstrations. Orion will make its multi-day outbound trip to the moon, propelled by a service module provided by the European Space Agency. Engineers will test Orion's systems on the way to the moon, Then Orion will fly about 60 miles above the lunar surface, using the moon's gravity and engines on the surface module to enter a lunar orbit. After about a month and a total distance of over 1 million miles, Orion will return home faster and hotter than any spacecraft has before. A primary goal of Artemis 1, ensure Orion safely returns to Earth before we fly with humans. When we do, we'll build our capability for sustainable lunar exploration, preparing us for missions farther into the solar system.
Initially, what we'd like to do is start establishing a presence on the moon. So we're going to establish going back there on a regular basis, and then we'll end up setting up Gateway, and we would launch to the Gateway, and from Gateway, land on the surface of the moon.
We are there for weeks, months on end. And there we're going to be able to test out all the hardware and the habitats and the hatches, the suits and the rovers that'll allow us to prove out those technologies. The moon will lead the way to Mars, and we should be there in the next couple of decades.
Are you thinking of some good questions right now?
Yeah. All right, well, you guys may question, why are we going back to the moon since we've already been there? Well, we're going for many reasons. It's a natural stepping stone to go to Mars. We will demonstrate new technologies, capabilities, and business approaches needed for exploration further into the solar system, which includes Mars. On the lunar surface, we will pursue water from ice and other natural resources to further our journey, and then we'll secure America's establishment into the space exploration and establish a strategic presence on the moon. And then we're going to broaden our industry and international partnerships and exploring the moon together. We will inspire the new generation and encourage careers in STEM, which is why we're here today. And then you can see there a little further onto that. All right, so let's talk a little bit more about SLS, which again stands for Space Launch Systems. This is the biggest rocket built in the world. And how amazing is it that that's here in America? It is the heaviest and it has the most power. It is the only exploration class vehicle that's capable of sending the humans into deep space, along with large systems necessary to live and work into deep space. It is the power and capability to lift large and complex payloads, which is reducing the number of launches that is needed to put hardware into space. So the more that you can put on one spacecraft and send up into space at a time, the less that you have to launch. It stands 322 feet tall and it weighs 5.75 million pounds. And when it lifts off, there's 8.8 million pounds of thrust. Yeah, that's a lot. And then the design allows for more mission flexibility to carry equipment and astronauts on an exploration mission or a large telescope for specific science reasons. The SLS's secondary payload capability enables a CubeSat or small sat technology to be delivered into deep space. Every launch will offer a new opportunity for different sciences. SLS is a foundational asset for America's space program. One piece of deep space architecture to journey into destinations like Mars and then hopefully beyond from there. All right, and this side you can see just how big SLS is. As a fun reference, you have the Statue of Liberty right here. It's 305 feet tall, and that is huge. But SLS is bigger than that. It's 17 feet taller than that. You can see right here, it's 322 feet for the Block 1. The Saturn V is the tallest at 363. But these things are huge. And you can see a fun image there of the animals and the human standing next to these space shuttles. All right, and then for Artemis 1, it'll be able to carry 154,000 pounds of supplies. That's like lifting 12 elephants up into space, which is amazing. So the future missions to Mars will require even more of supplies. So the larger versions of SLS will be able to carry 286,000 pounds of supplies, which is like 22 elephants up in space. All right, and a little further on the different components of SLS. So first here on the left, you'll see the boosters. The boosters are what I'm most familiar with here at Northrop Grumman, because that's what we manufacture here in Utah. They're similar to what were on the space shuttle boosters. However, they're larger. They have an extra segment on them. Instead of having 8 total segments, they have 10 now, which means more propellant inside of them. It also features new avionics and more environmentally benign installation and other upgrades on them. So fun facts about the boosters. Each of these boosters here on the left are 177 feet tall, or 17 stories taller than the Statue of Liberty. Each booster burns about 1.38 million pounds of propellant in just 2 minutes. So that's an average of 5.5 tons of propellant every second. Each booster thrust is greater than 14 4-engine Boeing 747s at takeoff power. So these things are massive. And here in a few slides, you'll see a video of us demonstrating the test here at Utah. We do what we call static tests, where they stay in a stable position, and we burn them to just make sure that it performs as we had hoped and designed, to make sure that we are testing out our new technologies and prove them for flight. So then the engines here that you see next to the boosters, there are 4 RS-25 engines, which is versus 3 of them that were made on shuttle. They have a new controller and software and nozzle installation. So they are underneath that core stage, and there you can see 4 of them there with the red circles. So some fun facts about the RS-25, they're high pressure fuel. It generates 100 horsepower for each pound of its weight, while a car engine generates about half a horsepower for each pound of its weight. I'm sorry. All right, and then the core stage next to that. The core stage is the tallest rocket ever flown. It's in the middle of the 2 boosters, and it will be 212 feet tall, and then 27.6 feet in diameter. This is a little different on the propellant. This is a liquid versus the boosters is a solid propellant. The liquid hydrogen tank measures more than 130 feet tall, and it comprises almost 2/3 of the core stage, and it holds 537,000 gallons of liquid hydrogen. And that's cooled to a minus 423 degrees Fahrenheit. All right, and then you can see here on the right, that's the upper stage, and it's the interim cryogenic propulsion system and Orion stage adapter. And that is for both in the space station processing facility at Kennedy Space Center, and then it's needed until further stacking. All right, so who's ready to see a video of what we do here at Northrop when we test them? All right.
Four, 3, 2, 1, 0.
Did you know that Northrop Grumman does these tests on different topics too? And sometimes they're open to the public. So you can go to this car up there and park and watch what the test going on.
All right, so even though that is really quick, that is 1.3 million pounds of propellant. That burns in about 2 minutes, which is really exciting. And that is only one side of the boosters, and there's 2 boosters on the SLS motor. So it's twice that power, and that's how quick it goes. All right. So a little bit more about Orion. So the Orion is designed to accommodate 99% of the human population, which it's a larger range than NASA has ever had. It can accommodate astronauts as small as 4'10" or as tall as 6'5". It provides about 30% more cubic volume of space than the Apollo capsule. The Orion's heat shield withstands temperatures about 5,000 degrees Fahrenheit during the re-entry back into the Earth. And then you wonder, how hot is 500,000 degrees Fahrenheit? Well, that is half the temperature of the sun, which is crazy hot. So returning speed, it's way faster than the speed of a bullet. The Orion will be returning to Earth from the moon at speeds of 25,000 miles per hour, which means that it could travel from Los Angeles to New York in just 6 minutes, whereas on a commercial flight, that would take about 5.5 hours. All right, and then here's a little bit more about the Orion. It breaks up into these different modules. Here at Northrop Grumman, we build the section towards the top, the abort motor. If they would need to use that, they would break off with that motor in an instance. So we're going to show next that launch abort motor that we build here at Northrop Grumman, the test that we did for that.
So this is the part of the spacecraft that keeps the astronauts on the launch. This part was fire, and it would pull the Orion capsule with the astronauts aboard away from the rocket so that if it exploded, they wouldn't get hurt. Oh.
All right, so that launch abort motor is very important for the astronaut safety. If they were to need to use that mechanism, it quickly gets them away into a safe location. All right, next you can see here, this is a really exciting building. So the Exploration Ground Systems, it's based at NASA's Kennedy Space Center here or in Florida. It's established to develop and operate systems and facilities necessary to process the launch rockets and spacecraft starting assembly. So the SLS core stage will arrive at Kennedy Space Center. The one for Artemis 1 arrived on April 27th, 2021, and it was transported to the Vehicle Assembly Building, which is this really, really, really tall building that you can see here. It began building on April 29th, and the EGS attached the core stage to the 2 solid rocket boosters. And then they stacked the Orion on the top that you can see there. The Artemis 1 then rolled out of the VAB into the launch pad on March 17th, which is where they conducted the wet dress rehearsal, which is a series of testing that is needed to be done prior to launch. Once they did that, they rolled it back in. And then they did a second wet dress rehearsal later on after that. And then currently they passed that and they're back in the VAB doing some final launch readiness tests. And then they'll roll it back out and then we'll get ready to launch on August 29th. So this is.
Sorry, in a wet dress rehearsal, they all of the fuel into the rocket so they can see how the rocket is going to handle that fuel and make sure all of its systems work correctly.
Yes. Thanks for adding that. It is a very important step prior to launch because we want to ensure the safety of our astronauts. Even though this one is uncrewed, we still perform necessary checkouts. And then some fun facts about this building that you can see here. It is one of the largest buildings in the world. It covers 8 acres. It's 525 feet tall and it's 518 feet wide. It has the doors that you can see here are the largest doors in the world. They're 456 feet tall and they take about 45 minutes to completely open or close them. The building, you can't see it in this picture, but it has the largest painted American flag on it in the world. The flag is 209 feet tall, 110 feet wide. And it takes 600 gallons of paint to be able to paint that on there. All right, next you can see how they transport the SLS rocket. So they use this thing that's called the crawler. It's the size of a baseball field and it's powered by a locomotive and large electrical power generator engines. It's very unique and it was built in 1965 to move the Saturn V rocket, just like they do with this one, from the VAB to the launch pad. So they use this crawler to roll it out for the wet dress rehearsal, and then they'll use it again when they get ready for launch. The crawler is able to transport 18 million pounds. That's the weight of 20 fully loaded 777 airplanes, and it moves about 1 mile per hour. When they move this out to go to the launch pad, it takes between 8 and 12 hours to do that, because it really takes after its name. It crawls. It is very slow, but it gets it there in a safe position. All right. And this, you can see a rollout of the laps of how they move it. All right, so that was obviously a lot quicker than it happens in real life, but it's so incredibly huge. You can see how small these people are compared to that building. All right, so where are we currently at with the process here? As I mentioned, we had performed a successful wet dress rehearsal. The SLS Artemis 1 is back in the VAB, finishing up last touches prior to rollout and a launch targeting no earlier than August 29th. So I hope you guys all have a chance to be able to watch that. It's going to be very, very exciting. All right, and there's another view there of the Artemis. Okay, and then real quick, a little bit more about the further missions. Artemis 2 is going to be the first flight of the crew to the moon aboard the SLS and Orion. So it's just going to be like Artemis 1, but this time it's going to have a crew. The crew will include astronauts, and it will be estimated 24 hours in the high Earth orbit before heading into the lunar orbit. Artemis will take place no earlier than 2024. And let's see, next slide here, Artemis 3. This is really, really, really exciting. Artemis 3 is going to land the first woman and the first person of color on the moon. We have not been there in over 50 years. So this is really exciting to be able to be a part of that when we go to that.
Can you tell them what the time frame is for that?
It's going to take place no earlier than 2025 currently.
So in just a few years, you will be able to see people walking on the moon again.
All right, and then here's a little bit more details about the missions. You can see here the path that it is going to be following. If you kind of like connecting the dots, this is the SLS motor here. It's starting around, going to go around the moon. You can see the Orion going here, separating off, or around the Earth, sorry, and then it goes around the moon here. And like it mentioned in that video, it's going to be about 60 miles above it. And then it'll go right here, which then it rotates back around and then comes back and re-enters into the Earth's surface.
When you get out to this point, that's the furthest any human has been away from planet Earth. So those astronauts that are aboard that on Orion, or I mean on Artemis 3, they will go further away from Earth than any other person ever has before they go back to the moon.
Yes, it's very, very exciting. And then you can see here's Artemis 2. This is what's going to be the crewed spacecraft. We'll have the astronauts on it going around the moon again, and then it will head back. And then here's Artemis 3's. You can see it goes again around the moon or around the Earth back, and then here on the moon, and then it has an ascend and descend, and then it heads back into the Earth's orbit. So that it further details it, but it's really, really exciting that we're going to be able to do that. All right, and then as the video mentioned briefly, there's the gateway, and it's an expanded configuration. It's going to be a robust operating laboratory and a home away from home for the astronauts on their way to and from the lunar surface. And what's really exciting, you can see here, it involves many partnerships to be able to make this happen. And then here at Northrop Grumman, we do what's called the HALO, the habitation and logistics outpost right there in the middle. So it's really exciting to be able to be a part of that. All right, and that is all I have. Feel free to ask any questions.
Oh, that's not on anymore.
No, there we go. All right. So I have been kind of wandering around in the audience a little bit, and I know we've got some really good questions coming up. So this is what I would love you to do. We're going to form a line right down here, center aisle. If you have a question, you can ask one question, but if you have more than one, you can go back to the back of the line and come through again, okay? We just want to make sure everybody has a chance to ask a question that wants to. Okay, so go ahead and line up right here. When you get up to ask your question, make sure you say it really loud so that everybody can hear you. You're going to say it right here in the microphone, really loud, so everybody can hear you, okay? All right, everybody get lined up? Okay, come right up here so you can ask the question. Say, hi, my name is, and for your first question.
Hi, my name is Blake, and my question is, how long can you stay in space?
That's a really good question. It is not one I really know that question to, or the answer to, but I can tell you it depends on the spacecraft that they are brought into the atmosphere or into the orbit with. And it depends on the equipment and the food and supplies that they have. I'm not quite sure the answer to that though, for the total amount.
I can answer that if you'd like.
Yes.
So typically when we send astronauts to the International Space Station, they're there around 6 months. Sometimes they stay closer to a year, maybe a little over a year if it's a special mission. But when we go to the moon for the first surface mission on Artemis 3, we'll be there for about 6.5 days, which is longer than we were on the moon for any of the Apollo missions. And then each time we go back, we're going to stay a little bit longer until we can work up to the point where we're staying on the moon for months at a time. It's a great question.
I would like to be a rocket scientist too. And so what would I study in high school or junior high?
That's a really good question. Where I work at, there's many different engineering career paths. I was a chemical engineer. I work highly in the tooling engineering department right now. The tooling is what helps hold and make all of these boosters that we do here. A lot of those engineers are mechanical engineers. We have a lot of electrical engineers. There's a lot of computer science involved. Really, there's any kind of engineering career path. There's aerospace engineering. Just having the love for space, you could really find any kind of type of engineering or degree to get you involved into it.
Thank you.
Yeah.
Hello, my name is Connor. And I had a question. What are the rocket ships usually made out of?
That's a good question, and it depends on the rocket ship. So for ours, for example, the boosters that we manufacture, they are a steel case, which is then lined and then insulated and then filled with solid propellant. So the solid propellant has different formulation, which then cures into about the consistency of an eraser, which is very unique to Northrop Grumman. We build the solid propellant boosters here. The core stage in the middle, like we mentioned, is a liquid propellant.
Hello, my name is Quincy.
Hi. I can't hear him, sorry.
He asked how long it takes to build a rocket.
That's a good question. So for the boosters that we manufacture here, from the beginning to the end, we could build one segment. And like I mentioned, there's 10 segments involved in this SLS system. We can build one segment in 6 months. We do that in parallel with multiple in the process line. It's like a really, really large assembly line. So it begins at the very start where I said we build the steel cases. We line them, insulate them, they go through that process. And then another will come in and do that same thing at the same time that first motor is going on to the next process. So we can do it in about 6 months start to finish, but we do multiple in parallel.
So they're building more than one at a time.
Thank you. How Orion rockets do you have?
I couldn't hear that one, sorry.
He asked, how many Orion rockets do you have?
Orion? I don't have Orion here at Northrop. We build the boosters, but on the SLS, there is one on the top.
And they're working on the second, the third, and the fourth right now. So just like she was talking about how you can build lots of different parts of the boosters at the same time in the manufacturing line, they do the same thing with all the different rocket pieces. And so all of them up to really Artemis 4, there's different parts of the SLS and Orion that are all being manufactured right now.
Hello, my name is Gabriel. Hello, my name is Gabriel, and I was wondering how much gallons of fuel is in the rocket plane.
In the rocket. So in the boosters that we make, there's pounds of propellant rather than gallons.
They're solid. It's a solid rocket. Kind of
Yep.
like inside of your fireworks, but much
And
better.
it's 1.4 million pounds.
That is a lot.
I'm sorry, I can't hear that one.
Aria would like to know if aliens are real.
We'll see what the astronauts say when they get back.
Aria, so far we have not found any real aliens, but we hope that someday we will.
Nobody knows if they are.
We are going further than we've ever been, so.
Hi, my name is Ashley, and my question is, how long does it take to get to space?
How long does it take to get to space? That's a good question. And again, it depends on the path that they're going to be going into. Patricia, you might be able to better answer that on average. I don't know.
So on average, for space shuttle and even for the SLS, they consider space about 8 to 8.5 minutes of flight. And then you're in orbit around the Earth. And then from there, you know, to go to the moon, that takes another 3.5 to 4 days. And so to get to what we call Earth orbit or low Earth orbit, where we're away from the majority of Earth's atmosphere and we're in And microgravity, because we're falling around the Earth, it's about 8.5 minutes.
That's not very long. It doesn't take very long.
It's quick.
No, you have to think about it. The space station is only 250 miles straight up. You know, so it's really not that far, but it takes so much power and so much effort to get that far. It's a lot easier to go, you know, on the ground 250 miles, and it's really hard to go up 250 miles.
So how many of you have ever been to Idaho Falls? Okay, so the space station is really about the same distance from here as Idaho Falls. Actually, Idaho Falls is slightly further, but you can't drive from here to Idaho Falls in 8 minutes, can you? So that's how fast those rockets are going. They're going super, super fast to be able to break Earth's gravity and get to the space station. And when they go to the moon, they have to go super fast to get that far too. But that's going to take about 4 days to get that far. So even though they're going super, super fast, that it's going to take them still 4 days to get to the moon.
So a fun fact about that is to get in orbit around the Earth where the space station is, we're traveling at 17,500 miles an hour. To escape Earth's gravity, we have to travel about 25,000 miles per hour. So it's really fast to get away from the moon, or to get away from Earth. We have to have a lot of power.
But my question was, what is the name of the first woman who's going to land on the moon, and why was she chosen to do it?
I'm not sure the names. I don't know. I don't think they've picked quite yet.
No, they haven't picked. Yeah.
There's
Don't know
some
yet.
that are in that pool that can be chosen, but we don't know who's going to be for sure yet.
We'll know who the first crew on Artemis 2 is probably by the end of this year. And then maybe a year and a half later, then we'll know who the crew for Artemis 3. They don't usually announce the names of the astronauts until about a year and a half to 2 years out before the mission, because we don't want them to have what we call crew fatigue. So they're not training for a mission that takes forever to get to, right? So they only train for about a year and a half to 2 years before each mission.
So, I was wondering, what, besides learning more about the past of like Mars and the moon, what's the purpose of finding water on planets if we don't have any proof that life forms besides humans need water to survive? And there obviously isn't enough water to support humans if we're able to live on those places.
You know, that really is a great question. And that's something we're going to be furthering to research and find out as we go through these different missions. But right now, we don't have an answer. Unless Patricia, you know a little bit more about that.
No, the main reason for water is just for astronauts, right? To have a resource, you know, and you were right. We don't know for sure if there are any living organisms in that water. We have no idea. You know, maybe we'll find something on the moon or even on Mars when we get to Mars. And if we find some water ice, maybe there's evidence of life. But like you said, there's the main reason for water is just as a resource for astronauts to breathe. We can turn it into oxygen. We can turn it into, of course, clean it up and make it a resource to drink, and even rocket propellant, you know, but that's the main objective right now. And we don't even know if we can take it and turn it into those things. We're going to practice. We have to bring the equipment with us and try to get the water ice deep in from the craters and then turn it into a resource we can use. And that's going to be pretty hard to do, but we need to be able to do that to learn to live on another world.
How long are you going to be on the moon other than just the ship?
So like Patricia mentioned, when we go there for Artemis 3, it will be about 6 days. And then with furthering missions, we will extend that time.
6 days on the moon.
Mm-hmm.
Is it scary when you launch a rocket
Is it scary when what?
When you launch the rocket.
So for me, it's fun and it is exciting and I love it. But I will say my 3-year-old daughter, she just came out and saw that static test that you saw in the video, and it did scare her. So there is like a pressure wave that comes. You don't hear the noise for a while, you just see it burning. And then it gets really loud, and that can shock people with how loud it really is. So it can be a little scary to some, just based on how loud it is and the crackling noise of that propellant when it burns. But for a lot of people, it's also very, very exciting.
And my question is, if all the propellant were to explode all at once, how big would that explosion be?
Honestly, that's kind of what it does when it burns. It lights from the beginning where the igniter is at the very, very tip top of the booster, and it burns in 2 minutes and that 177 feet of propellant. So that it really is burning almost instantly. And so, like we mentioned, the whole rocket's 8.8 million pounds of thrust, and it's a lot of fire. So it's a big.
I'm even first, and I don't want to know what it feels like in a rocket ship.
What it feels like in a rocket ship. I don't know, but I'm not an astronaut, but I was actually talking to an astronaut a few weeks ago, and he was telling me that he had never seen one of the static tests that we showed in that video. He had just seen them from when he rode in the spacecraft and saw them separating as he was flying in them. So that was a completely awesome experience to hear versus, my experiences seeing them tested. So I don't know what it's like in there, but just talking to the astronauts, it seems really amazing.
I've heard that that when they light your boosters, that it feels like they got a kick in the pants. That's what they've heard them say, because the engines at the bottom, well, on the space shuttle, the boosters and engines are very similar. They're just more powerful. And so on space shuttle, there were 3, and those engines fire for a few seconds, but the vehicle doesn't move until the boosters light. And the astronauts will say it feels like you get a kick in the pants as soon as you're pushed against the seat, kind of like you would on a roller coaster when you go down that big hill and then you come back up and then you're like, ooh, like this. They say it's a kick in the pants, and you're going when the boosters light.
I didn't hear that one.
I didn't hear it.
I didn't hear it again. Sorry.
How big is a rover?
A rover. That is a very good question. I don't know that, Patricia.
I actually have a picture. I'm going to try to show it to you guys. So it depends on the rover, just like Jessica was saying. Everything depends on what we were talking about. If it's a spacecraft or if it's a rocket, they're all different shapes and sizes. And I will show you guys a look at one of the rovers on Mars right now, if I can make my screen sharing work. Let's see if it works. Let me see it. Can you see it or no?
Yeah.
Okay, good. Okay, good. All right, good. So this is a picture of a Perseverance, sorry. And Perseverance is the most recent rover we put on the Mars in 2020. And it is the size of a small SUV car. So it's pretty big. There's been some that have been the size of golf carts, some that are the size of like a super small robot that would be maybe the size of a microwave. But the biggest we put is the size of a small SUV.
We have an extra special opportunity right now. If you would like to go to Clark Planetarium in Salt Lake, which is just about an hour south of here, 45 minutes south, they actually have a full-size model of the Perseverance rover right now in their lobby. And I was just down there a couple of weeks ago, working with the people from JPL to introduce that to people. So you can go down and actually see a full-size model, so you can see just how big it is and exactly what it looks like.
How many rocket ships has NASA launched?
How many have they launched?
Yeah.
Oh, that's a good question. More than I can count, probably.
I don't know an answer either. I'd have to Google it and see if the Google knows, if the internet knows how many, but definitely hundreds for sure.
And they launched a whole lot of rockets back even before they went to the moon the first time.
Mm-hmm.
Yeah.
And so long. That is super crazy. How many G's would the astronauts feel when it launches?
Oh, good question. I don't know that answer either. I think it also depends on the power of the individual spacecraft.
Like the one
Yeah.
about the Saturn one.
So the space shuttle was about 3 to 4 Gs. I think the Saturn V was a little bit more. I can't remember. And so the SLS would be comparable. It won't be so much that they'll pass out. You know, they can handle it. It's not that bad. If Orion's launch abort system deploys, that's like 9 Gs, 8 or 9 Gs. That's pretty tough. And so the astronauts might stay awake. They might pass out. We don't know. You know, everybody has different tolerances. But SLS is safe so that they can do their jobs as they're launching. They'll be awake the whole time.
How do you find out about launching the rocket?
Sorry, what?
She is asking how you find out about the tests that Northrop Grumman does so they can come see them.
Oh, that is a very good question. I know they communicate it through various different channels. Kendra, do you know how we specifically communicate it to maybe the schools? Maybe Kendra's on.
I'll find out. Kendra and I
Yeah.
will talk after the program, and we'll find out how you guys can drive and watch it. Because I know that there's public viewing part, because I've seen one too, and there's an area for the public, and then there's part for the employees too. So we'll find out and we'll get that info to the library.
Yes, thank you.
My name is Greta, and I was wondering, so I love math, and I was wondering what jobs at NASA use the most math.
All of them.
Oh, that is a really good question. So a lot of them would use math, you know, any type of engineering. There's also, you know,
They use a ton.
accounting, economics. There's so many positions involved in making a rocket that you don't even think about that might exist. You know, one of them, we have to calculate how much materials we need to manufacture these. So that's also a different type of position that's not specifically engineer, but it does highly involve math, knowing how much materials we need to have up front so it's ready for when we manufacture. And that's here at Northrop Grumman. At NASA, I would assume that there's many different opportunities that involve math.
We use math every day.
Yep.
Even for someone who didn't get has a math background, communication folks, I mean, it's important to know we use math all the time.
Yes, I mean, talking about the numbers and the propellant and the thrust that this gives, it's math.
And orbital mechanics, that's another place where they use a lot of math. And computers. Okay, so we are getting close to the end of our time. So we're going to take these 4 questions and then we're going to stop. And then if you will mind holding on for just another minute at the end, I'm going to tell you about some programs that we've got going on here at the library over the next few months so that you can get more space in your life.
My name is Hiram, and I was wondering, how do people go to the bathroom in outer space?
Patricia might have to answer that one.
Yeah, I I don't know if I'm fast enough to pull up the video, but I do have a video of an astronaut that's kind of talking about it. It might be easier just to show you guys what it looks like without the audio, because it's usually pretty choppy. But imagine a very, very small porta potty. You know, that's pretty much what it is. And one of the big differences about going to the bathroom in space as opposed to going to the bathroom on Earth is that everything floats in space, and you don't want your business floating up behind you, right? No. So there is something called a negative airflow, which is basically like a vacuum that sucks all of the liquid waste and the solid waste away from you. So I can't find the video, I'm not fast enough, but imagine putting a tube against your body to do your business, to do number one, and it sucks all the liquid waste away. And on the space station, we recycle it and we purify it, and then the astronauts can use it as drinking water the next day. Yeah. And then when you need to do number two, you do your business and you push a button and it sucks the solid waste away, and it's stored in a container that traps all the smells and the grossness of your waste. And then we don't recycle that. We just get rid of it later. But you have to practice. There is a room at Johnson Space Center where astronauts have privacy, and they go in and they practice using the space toilet to make sure they have a good seal and that they know how to use it once they go into space. Yeah.
Astronauts have a saying. They say that yesterday's coffee is tomorrow's coffee.
All right, it looks like we maybe have time for one, maybe two more before we hit the top of the hour.
Hi, my name is Gabriella, and what's the prettiest thing you found in space?
What's the craziest thing they found in space? I don't know.
I guess that's relative, like to what you think is crazy.
I think moon sand is pretty awesome. I'm not
They
sure.
found some really cool things on Mars that geologists got really excited about. So I guess it depends on what gets you excited, right?
Wait, of all rockets that NASA has ever launched, how heavy were they?
How what?
He's asking if you added all of the weights of all of the rockets that NASA has ever launched, how heavy would that be? And I would just like to add very heavy.
Yeah, I'm not sure, but yes, a lot.
That would take a lot of.
I don't know if
how much they all weigh.
I don't even know if anyone's ever calculated that before. That might be a really cool math problem for you to do later this summer.
Oh.
Yeah.
How many there are and how much they weigh, and add them up and let us know.
Yep. All right, one more and then we're good.
Does NASA, once they land the rockets, because I heard that sometimes they land them on like Air Force runways, do they reuse them after that?
Do they reuse the rockets after they've used them?
Some components.
The parts and pieces of them they do.
It depends on the rocket, right? So every rocket's different, every spacecraft is different, and sometimes we can reuse all of it, sometimes we can reuse part of it, and then sometimes we can't reuse that piece. It just depends.
All right, we would like to give a very special thank you and applause to the Thank you so much for coming and sharing all the great information with us. Now, I wanted to give you a little bit of a heads up about some of the programs that are going going on here at the library. We actually do space days at the library quite often. So if you keep an eye on the announcements from the library, I'm here doing presentations about once a month. So keep an eye out, and we'll have different subjects. We've got a couple of things that we know are coming up soon. One is we're going to do a presentation about perseverance coming up pretty soon. And we'll talk about the rover Perseverance and how it works and what it's doing on Mars. Another one that will happen in the beginning of the next year, I'm going to do an analog mission at the Mars Desert Research Station. So I'll be pretending to be on Mars. So when I get back from that, we'll do a presentation on that, and I'll tell you all of the things that I learned about Mars while I was doing that. And then here's another one that is really good for any of you who are 6th grade and older. And if you know anyone who is 6th grade and older and would like to be involved, please let them know. the library is going to have a program where you will be able to grow plants in a specialized veggie unit that is very similar to the ones that are on the International Space Station. And you'll be able to figure out how to grow plants so that astronauts can grow them on Mars. And I've already heard that some of the things they're looking at growing are herbs and spices. So you'll get a chance to do that. It's only for those who are 6th grade and older though. Okay, so 6th grade to 12th grade. So if you know anybody that are in those grades and would like to be involved in a space project, that is available. Now, the information that we learned from that project is really going to NASA. We're really sending that information and they're really using it to study how they can grow plants in space. All right. Well, be sure that you are watching the announcement library. Don't miss out on these programs in the future, and let's everybody wait for us.
Thank you so much. Thanks, Jessica.